So we're continuing along with our hydrocarbon derivatives, and we're going to move into the alcohol family. Okay, so we have something other than C and H, which makes it a derivative. The unique functional group, hydroxyl, is referred to as a functional group. You may be asked, what is the functional group that makes this a member of a family, or identify the functional group in the diagram in a question. Okay. Now, so the functional group is a hydroxyl group. I really want to emphasize that this is not hydroxide. OH minus is an ion that you're going to find in an ionic compound. This OH is covalently bonded to something. That's why I have that little dash. That dash is a pair of electrons going to a carbon is all we're going to see in this particular course. Okay, so covalently bonded. Okay, so do not identify OH minus hydroxide as being an alcohol. Okay? No, so calcium hydroxide is not an alcohol. Okay? It's an ionic compound. Okay? So the addition of a hydroxyl group to a hydrocarbon, okay, which makes it a hydrocarbon derivative, is in the alcohol family, and you're going to see this OL ending show up at the end. So instead of an ane or an ene or an ine, you're going to see OL. Okay. Naming and drawing is what we do next, or we've been consistently doing next. So naming, alcohols are going to be based off the alkane stem. Okay, so carbons with all single bonds, we're going to take that alkane stem. We're going to drop that last E in the alkane name. So hexane, or ethane, or propane. We're going to drop the E and put an OL to tell the reader that there's an OH added in. Okay. Once we put in some coded information, we often have to tell the reader where is it. Okay. So a number may be required to tell the reader where that hydroxyl group is. Most of the time you'll need a number. Okay. Sometimes you don't need a number because there's only one possibility. So let's look at a bunch of drawing and naming examples. So I'm going to start with a structural diagram. 3 carbons. And I'm going to dash off the carbon to an O, dash to an H. So that's what a hydroxyl looks like. Naming pretty much the same. We always start with the stem or parent. In the case of alcohols, we need to find the longest chain that contains the hydroxyl group. Okay, if we had a double bond, we'd find the longest chain that contains the double bond. So our chain is prop. Now I'm going to erase the E. So we've got a propane, but we take away the E. We're going to add OL, and we need a number to tell the reader where where the hydroxyl group is located. The shortest way visually is from the right, and it is coming off the very first carbon. That would be the second. That would be the third. So this is propane 1 all. Okay. I need my number because there's another isomer that would be propane 2 all. It could be in the middle position. Okay. So we need the number to tell the reader it's not in the middle, it's at the end. With alkyl groups, you could never have ones. But with organic halides, you could have a chloro at an end, or you could have a hydroxyl at an end. Okay? But you couldn't have a methyl or an ethyl at the end of a molecule. Line structure, fairly similar. We're going to have to write that O in after we get out the stem. So 1, 2, 3, lift my pen. Then on the end, I'm going to have to put another line segment that has a O at the end. So that's the O of our hydroxyl. And then we do write in H's when they don't connect to carbons. So all the other H's are dropped, but because that H is not carbon connecting, we write it in. To help the 3 carbons pop out, I'm going to use my strategy of circling the ends of line segments. I need to add a little bit to that. I'm circling the ends of line segments that don't have letters at the end of them. I'm not circling the end of the line segment next to that O because there's no carbon there. So that was a simpler example. I'm going to throw a branch and a hydroxyl group into my next example. I'm going to go up to 4 carbons. And then everything's connected in the middle. Nothing is at an end this time. So my first thing I deal with, what's the longest chain that has the family member in it, the hydroxyl? So 1, 2, 3, 4, 1, 2, 3, 4. There's 2 different 4 long chains, so I have to pick one of them. I'll pick the right to left, which leaves, we have a 1 carbon branch coming off, a methyl, and then we've got a hydroxyl, which sets the family. The same way that you would deal with a double or triple bond first, you're going to deal with the family first. So I've been keep saying this break ties alphabetic, but we're not to ties yet. We're still in step 1 or 2 when I gave my list. We're dealing with the family. The shortest way to get the hydroxyl, which sets the family, is from the right. So I'm going to number from the right. Okay, so first part is always the stem, bute. Okay. Now with alcohol, you go ANE, drop the E. The hydroxyl is 2 over. Okay? So we wouldn't even look at alkyl groups yet. We wouldn't even factor them into the numbering or what side. So we minimize the side to the hydroxyl. 1, 2, 3. Then we deal with the front, and that methyl is in the 3 position. So it's been a few lessons where we prioritize to the family, an ene, maybe a double bond, and then dealt with the sides. Let's do with the line structure, and then we'll move on with some more alcohol information. 4 carbons, 1, 2, 3, 4, lift, and then we have 2 different things to put in. I have to put a hydroxyl on the 2nd carbon. Now, whether you go up or down doesn't matter. So we've got our 1st carbon, our 2nd carbon, our 3rd, and our 4th. I'm going to take those numbers away, but that's our numbering. So our 2nd carbon is a down one, and just because I have more space, I'm going to go down with my hydroxyl. I could have went up, it was just a bit more crowded on my board. I went down to the O and then to the H. Okay. Then I have a methyl off the 3rd carbon. Methyl is 1 carbon, and branches, I drop my pen and say 0 because there's already a carbon there. That's a stem carbon. 1, lift. So 0, up, 1, lift. and that will be a methyl. So that is the line structure for 3-methylbutane 2-ol. Some of these are quite a mouthful, but there's no vocabulary test to worry about. Okay, so that's our intro. 1 hydroxyl group, next 2 hydroxyl groups. Okay. This leads to a rule that I personally think is dumb and I dislike it, but nobody cares my opinion. IUPAC makes the rules, I follow the rules. You follow the rules if you want to get things right. So alcohols with more than 1 hydroxyl apply all the same rules except for, and this is what I think is silly, you don't drop the E. I don't know why. Ask phone IUPAC. Why do you keep that silly E? The rest would be as expected. If there's more than 1 hydroxyl, you're going to use prefixes, di, tri, tetra. If there's more than 1, you're going to need more than 1 number. That's expected. We just have that E that we don't drop. So that is not a typo. In propane 1,2,3-triol, it is supposed to be there. It's probably there for phonetic reasons. Sounds nicer. So in decoding this name, I'm going to go to a line structure. Same sequence, deal with the stem first, the ending, and then go to the front. There's actually no side groups here. There's no YLs. The stem is propane, so that's 3. 1, 2, 3, lift. Then we go to the very end, and the family, we get OL to decode, and that means alcohol. There's some hydroxyls. Triol, 3 hydroxyls in the 1, the 2, and the 3 position. So I'll do this from the left. There's the 1 position. There's the 2 position. And there's the 3 position. 1, 2, 3. That's it. That would be the line structure for propane 1, 2, 3 triol. Now, occasionally I make mistakes. Should I have left those numbers out? Is there more than 1 isomer? Is there more than 1? We've got 3 hydroxyls. Do they have to be 1, 2, 3? It turns out I'm not wrong. I've not made a mistake, at least here. There are some other isomers. What are they? What other combination of numbers could you have? You have to realize every carbon, how many H's are there. They're not drawn in. Okay? If I focus in on that carbon, that's an N carbon. 1 bond goes to the second carbon. Another bond goes to the O to the H. That's 2. There's 2 H's where that green carbon is. You could have propane 1, 1, 1 triol. All 3 of them could be there. It would be an isomer. It has the same C and H and O count, but a different structure. You could have 1, 1, 2. You could have 1, 1, 3. You could have 1, 2, 2. There's actually a fair number of different isomers, different numbering counts. So I've not made a mistake here. One more example of a diol. Now, some of the outcomes of this course is to connect everyday compounds with what you're learning. So this really fits into that outcome. Okay, ethane 1,2-diol. You go to Canadian Tire and you buy antifreeze, this is what you're buying. F, 2 carbons, so a line would be 2 carbons, and it's a 1,2-diol, so the hydroxyl groups aren't at the same end. There's 1 at each end. And you can mix, it's incredibly soluble in water. Most cars in Canada, either 50-50 or 55% 45. Okay. Most cars in the US, 50-50 mixture is what's recommended. So half this, half water. Okay. Now, I'm a chemist, that's my training. I don't really get biology. It's fascinating how slight differences in atoms can have a huge effect. Okay. Ethanol is 2 carbons with just a hydroxyl group at one of the ends. That, when you turn 18, you're legally allowed to buy, at least in the province of Alberta, 19 in most Canadian provinces, 21 in most states, and this you can buy in beverages. Okay. You put another OH on it, and it's antifreeze in your car, and that's what I find fascinating about the slight differences in structure, how it has a colossal effect on the human body. Antifreeze is deadly. You cannot drink it. Ethanol is toxic, but you can drink it in low quantities, and it's okay. You take away 1 carbon, you go down to methanol. 1 carbon in a hydroxide, you go blind and you die. Highly deadly alcohol. Okay. People who make wine, which lots of people do, have to be really careful. Part of the winemaking process and the distilling of it is removing the methanol, heating it. The methanol boils off first, and you must throw that out. Okay? And then the ethanol comes second, and you can keep that. Okay? So there's a lot of chemistry in winemaking, things to make sure that it's safe. Okay? So that's an example of a diol, the antifreeze. Next slide will be quick. Phenol is one of those structures that is a combination of atoms that's so common it gets a special name. Like benzene just got a name because it's such a fundamentally important hydrocarbon. Phenol is an alcohol that just gets a name. Now we kind of see the PHEN kind of from PHENYL, which is an aromatic ring. And the OL is we have a hydroxyl replacing one of the H's. So this is phenol, and it's something you need to be aware of. Phenol is aromatic. It's an alcohol. It can do any of the reactions that we study in the future that alcohols do. Definitely doesn't fit in the human consumption category. One little last bit to do in alcohols, depending on where the hydroxyl is, it has a dramatic effect on the type of reaction. We're not going to use this, but if you take any university chemistry, you need to be able to identify primary, secondary, and tertiary alcohols and do something with it. We're just going to identify the type. So we're going to build a table with 4 total rows. I've got 2 hidden. I've got the secondary and tertiary rows hidden. Primary alcohols, I'll explain this better in a second. There is 1 carbon connected to the COH. So there's a carbon to a hydroxyl group, and there's 1 other carbon coming off that, is our definition of primary. Now give yourself lots of space to draw in the example that I'll do shortly. So what does this look like? Then I'll come back to the second row. So in my example, I must have a C to an O to an H. That's what I've circled in black. Okay? And I'll consistently do that in black, and then I'll switch to other colors. Okay? That black carbon has 3 more bonds that it can have. Okay? In a primary alcohol, only 1 of those 3 can be a carbon. So I'll put a carbon on 1, and I'm not going to fill that carbon in. That could be 2 in a row, 3 in a row, 10 in a row. Doesn't matter. And the other 2 bonds need to be hydrogen. So how many carbons are connected to the black C to the O to the H? just one. So this is what primary alcohols will look like. The hydroxyl is in the 1 position. It's at the end. So we're going to see a -1-OL in the name. These are very easy to react, and they do a particular type of reaction that you'd study in university organic chemistry, where you dive into use arrows to show the step and sequence that reactions occur. That's primary. We're going to reinforce that count. We're going to move on to secondary alcohols. Now there's going to be 2 carbons connected to the black C. So there's the black carbon to the O to the H, carbon to hydroxyl. Okay. Carbons have 4 bonds, which means there's 3 more dashes, or 3 more bonds. And now we're going to see 2 of those 3 remaining be carbons. Could be 1, 2, 3. The length doesn't matter. Okay. And the 4th bond is a hydrogen. Now these don't have to be 2 OLs. Okay. Okay. You can't just look at the name to figure out whether it's secondary. You have to look at that black carbon and do a count of what's around it. Okay. Last is tertiary. Not very reactive. Tertiary hydrocarbons have the hydroxyl kind of protected and blocked. There's C to O to H. Three more bonds. And now there's carbon chains of varying lengths coming off all 3 spots. There's no hydrogen connected to that black C. And that makes it tertiary. Slow to react, does a different mechanism, does different steps to react. Again, luckily, this might be the bane of some people's. Organic chemistry tends to be a hard course. Here, you're just going to learn in high school how to name stuff. What are the products? In university organic chemistry, you'd learn why does that reaction occur, or how does it occur? What steps occur? Okay? What bond breaks first? What bond breaks second? Which is doable, but much trickier. So that's our alcohol family. A bit of repetition. We got hydroxyl, not hydroxide. We got 1 hydroxyl. We've got 2 hydroxyls. We can name, we can draw, and then you've got primary, secondary, and tertiary.